Imagine a world untethered, a planet without a star to call home. This isn't science fiction. These are rogue planets, and our galaxy could be teeming with them. Today, we're going on an incredible journey. We go in to simulate what it would be like for a planet to be ejected from its solar system and sent hurtling into the vast, dark expanse of interstellar space. What would it see? What challenges would it face? And could it, against all odds, still harbor life? Let's find out. First, how does a planet go rogue? It usually starts in a young, chaotic solar system. Imagine a planetary nursery where newly formed giants jostle for position. A gravitational tug-of-war ensues, and sometimes, a smaller, Earth-sized planet gets the short end of the stick. A close flyby with a gas giant like Jupiter can act like a gravitational slingshot, flinging the smaller world out of the system entirely. At speeds of millions of kilometers per hour, its connection to its parent star is severed forever. As our rogue planet begins its lonely voyage, the first and most dramatic change is the cold. With no star to provide warmth, the surface temperature would plummet to hundreds of degrees below zero. Any oceans would freeze solid, from the surface down, creating a global ice shell kilometers thick. The atmosphere would condense, snowing out onto the frozen ground, until all that's left is a near-perfect vacuum. From the surface, the universe would look like a silent, frozen wasteland. But don't write it off just yet. While the surface freezes, the planet's interior could still be hot. Radioactive decay of elements in its core, a process that helps keep Earth's own core molten, would continue to generate heat. This internal furnace could be enough to maintain a liquid water ocean beneath that thick crust of ice. Think of it like Jupiter's moon Europa, but on a planetary scale and adrift in the void. So, our planet is now a dark, icy sphere with a secret, subterranean ocean. What is its journey like? For millions, even billions of years, it would drift through the near-empty space between stars. The sky would be a breathtaking, unchanging panorama of the Milky Way, far brighter and clearer than anything we can see from Earth, with no atmospheric distortion or light pollution. Nebulae would paint the void with vibrant colors, and the sheer number of stars would be overwhelming. But interstellar space isn't completely empty. Our rogue will occasionally pass through giant clouds of gas and dust, the same stellar nurseries where stars and new planets are born. Drifting through one of these nebulae would be a spectacular sight. The faint gas would be ionized by cosmic rays, causing it to glow in ethereal shades of pink and blue. For a time, our lonely wanderer wouldn't be so alone, surrounded by the building blocks of new solar systems. The biggest threat on this journey isn't the cold, but impacts. Without a massive planet like Jupiter to act as a gravitational shield, our rogue is more exposed to stray asteroids and comets. However, interstellar space is so vast that major collisions would still be incredibly rare, perhaps once every few million years. Most of its journey would be one of profound peace and solitude. Now for the big question: could life exist on such a world? On the surface, absolutely not. But deep beneath the ice, in that geothermally heated ocean, the story could be different. Here, shielded from the cold and deadly radiation of space, life could potentially arise around hydrothermal vents on the ocean floor. Much like the ecosystems we find in Earth's deepest, darkest trenches, life wouldn't rely on sunlight. Instead, it would be powered by chemosynthesis, drawing energy from the chemical reactions fueled by the planet's internal heat. Imagine a world of creatures that have never seen light, evolving in the eternal darkness of a subsurface ocean. Their world is one of pressure, warmth from the planet's core, and a steady supply of nutrients from volcanic vents. It's a completely self-contained biosphere, a living message in a bottle drifting through the cosmos. For these hypothetical life forms, the concept of a sun, a sky, or other worlds would be utterly alien. Their entire universe would be the warm water they inhabit. Over immense timescales, our rogue planet's journey might take it towards another star. What happens then? If it's a direct path, it could get captured into a new orbit. Suddenly, after eons of darkness, a new sun would appear in the sky. The ice shell would begin to melt, a process that could take thousands of years. The frozen atmosphere would sublimate, returning to a gaseous state. A new dawn would break over a world that hasn't known one for billions of years. This rethawing would be a cataclysmic event. Global oceans would reform, and the world could, in theory, become habitable on the surface once more. Any life that survived in the deep ocean would now be faced with a completely new environment, filled with light and new energy sources. It would trigger a massive evolutionary explosion, a second genesis on a single world. Of course, the chances of this are astronomically small. Most rogue planets will likely drift for eternity, their journey ending only when the universe itself grows cold and dark. They are cosmic nomads, silent witnesses to the galaxy's long history. But their existence raises a profound point. The conditions for life might not be confined to the cozy, well-lit orbits around stars. Life could be hiding in the dark, in places we've never thought to look. Scientists estimate there could be billions, perhaps even trillions, of these rogue planets in the Milky Way alone, more than there are stars. They are a huge unseen part of our galactic makeup. While we may never visit one, simulating their journey allows us to expand our understanding of what a planet can be. They challenge our definitions of a habitable zone and force us to consider that life might be more resilient and widespread than we ever imagined. These lonely worlds are a reminder of the sheer scale and wonder of the cosmos. Each one has a story, a history of its violent birth and its silent, endless pilgrimage through the stars. And deep within some, in a warm, dark ocean, that story might still be unfolding.